All right, let's go. Simple video. If it opens, there it is. Okay.
This video is meant.
And I want it in the minute 3:48 here. All right. Subtitle for you guys. And here we go. Ready? All right. Pay close attention, please.
So let's talk about conversion formulas. How do we go back and forth between polar coordinates and Cartesian coordinates? So what we'll do is we'll look at a point in the plane and we'll imagine that we've described both the Cartesian and polar coordinates for that point.
All right, take a look at this. This drawing is absolutely beautiful because in this little triangle, there is the explanation for both coordinates. You have the rectangular coordinates, right? The measurement of x in the x-axis, and then the measurement of y in the y-axis, right? These are the rectangular coordinates of this point. This point have coordinates x, y. Then this measurement, this measurement, right? But also in this drawing, we can see there is an elevation for the angle theta and also a distance from the distance, right? From the origin, sorry, that we call r. So this point also has coordinates r theta, right? In one drawing alone, we can show both coordinates for the same point, right? That's pretty cool. Let's continue.
So here they are, x, y, r, and theta. And we're going to use some simple right triangle trigonometry. So the ratio x over r gives us cosine theta, and the quotient y over r gives us sine theta. So here we have sine theta, and the quotient y over r gives us sine theta.
There, all right. Let's stop right there. You guys remember this, right? This is the simple use of SOHCAHTOA, something you saw, I don't remember when, maybe when you were in, when you were in 7th grade, maybe? I don't know, 8th grade? Maybe this year, but in another subject, physics or something like that, right? This is the use of something you guys call SOHCAHTOA. Now, I'm sure, just from hearing that name, some of you are going to go like, no. I'm sure about that. But I also know that you guys have been working with this, and you know this is simple use of calculator. Just define the division, right? The fractionary, and put it in a calculator, and you're done, right? I'm sure you guys know that. So that is what we're going to do today. Now, in case you don't remember, I am going to kind of explain what is this. All right, so the first part, this SOHCAHTOA is divided in 3 parts, right? The first part, the SOH part, is something that let us know that the sine of the angle is the opposite side over the hypotenuse, right? The next one, the CAH part, right? The CAH part is something that let us know that the cosine is equal to the adjacent to the hypotenuse. And in case you're still a little bit lost, wait. This sine is for S is for sine, right? Opposite O is for opposite, and hypotenuse is for H, right? It works also with cosine. So C is for cosine, adjacent is for the A, and H is for the hypotenuse, right? You guys know this, right? Give me 1 second. I need to sneeze. I'm back, sorry. All right. So if we do the tangent now, the last part of the SOHCAHTOA, this will be tangent, right? Is equal to the opposite over the hypotenuse, right? And these are just names, guys. These are just names. This sine, cosine, and tangent. These opposite hypotenuse, adjacent hypotenuse. These are just names, right? These are just names. What you do need to remember is that each and every one of these are formulas or buttons in a calculator, right? So if I open my calculator, which you guys are going to use right now, today you guys are going to have to use your calculator. If I open my calculator, you guys are going to see that cosine and all of this. Wait, give me 1 second. Let me open my calculator here real quick. There. All right, so you guys are going to notice that all of these measures appear right there in the calculator. All of these buttons. All right, let me show you my calculator. All right. So for example, the sine. This part, the sine. It is right here. What is it? Here. Sine. If you press this button, you're doing the sine of an angle. Right? If you press this button, you're doing the cosine of an angle. If you press this button, you're doing the tangent of an angle. Now, you don't do something like this. This will be the sine of the cosine of the tangent of the angle. Don't do something like this, all right? All right, beautiful. And now, these divisions, these fractionaries, are simply the locations of the sides in a right triangle. So, for example, the opposite of the angle theta, let's say we're doing the SOHCAHTOA, the trigonometry of the theta angle, the angle theta. So if we do this, we have that the opposite side is this one over here. This is the opposite side, right? This is the opposite side, right? I don't know if that's with double P or not. Now, simply because we're doing the trigonometry of the angle theta, this will be the adjacent. The adjacent will be this one. The measurement X. This will be the measurement of the adjacent, and this will be the measurement of the opposite, right? And the one that is missing, well, this one. This will be the measurement of our hypotenuse. This is our hypotenuse. All right? Cool. So now that we kind of remember this information, now we can do trigonometry. So if we study the cosine of an angle, the cosine, we know that the cosine, according to SOHCAHTOA, is the adjacent over the hypotenuse, right? So the cosine of the angle is the adjacent X over the hypotenuse, which is R. So it's exactly what we have here. The opposite over the hypotenuse, X over R, right? And if we study the sine, according to SOHCAHTOA, the sine is the opposite over the hypotenuse. Well, the opposite was Y. This is the opposite, right? You can see it right there, Y. And the hypotenuse is still R. So this right here, guys, is our trigonometry for this triangle. But we are not done. Why are we doing trigonometry here? Simple. Simple. Because we want to isolate the variables X and Y. And I'm going to show you why in a second. Let me erase all of this. Let me just erase all of this. Just erase all of these. There we go. And there we go. All right. Take a look at this. If we multiply on both sides of this equation by R on this side and R on this side, same here. R on this side and R on this side. R is a number. Remember, R is this measurement. This is R. R is this measurement, right? So if we take that R and we multiply it on both sides of the equation, this is what's going to happen. Look, this is what is going to happen. Look. The R and the R is going to get canceled. These and these are going to get canceled. And now we have effectively isolated the variable X and the variable Y. Now, why do we do that? Why do we want that? Because we want formulas to change from theta in R, from theta in R to X and Y. In other words, we want formulas to change from polar coordinates to rectangular coordinates. Let's take a look at the video.
So here we have simple equations which allow us to move from polar
Did you see?
to Cartesian coordinates.
The ones that I was showing you.
If we know R and theta, we can quickly generate the values of X and Y that describe the same point.
All right. Again, so if we have the values of R and theta, if we have those two values, then we can find the values of X and Y. These are effectively the conversion formulas to change from polar to Cartesian. Guys, I want you to please go ahead and write this down as soon as possible. And also, the people who don't have the camera open, go ahead and Turn on the camera. Turn the camera on. A lot of you had it on and then you forgot about it. Well, I don't. I don't forget about it because I'm seeing your faces. Right? All right. Now, let's take a look at some examples. This is the best way to practice this information with some examples. Again, if we have the polar coordinates, r and theta, these are the polar coordinates, we can change to rectangular coordinates. So now we can change from one to another with these two little formulas. How do we use those? Let's take a look at an example. Here, 6 comma pi over 6. These are polar coordinates, and the question is saying, find the rectangular coordinates of the points with the following polar coordinates. So these are polar, and the question is asking us to find the rectangular ones. All right? How? How do we do that? Simple. We are going to look, and we're going to use our two formulas over here in the corner. That is what we're going to do. So first, I want to plot the point because I want to know where is it? Where is it located? That location is going to help me know if I am doing a good replacement, if I'm using the calculator right or not. Sometimes, guys, we use the calculator and the calculator gives us bad information simply because we don't have it in the correct configuration. So doing this process may seem useless, but it's going to help you know if you're doing the things right or not. So if I plot this point, 6 comma pi over 6, we know that this is the point A, 6 comma 30 degrees. Pi over 6 is 30 degrees. It is positive, so here it is, the angle, right? Angle of elevation. Then distance from the origin of 6, that is what we have here, r is 6, right? So this is the point A, 6 comma 30 degrees. Beautiful. And we notice that this point is exactly in the first quadrant of the plane. Remember, this plane has quadrants, right? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? So we know the point A is in the first quadrant, quadrant 1. Now, why is that important? Because we know that both variables are going to be positive. We know that the x coordinate is positive and the y coordinate is also positive. Also, if we do this with some sort of software that lets us plot polar points, then we kind of know that the variable of x, the x coordinate is 5 comma something, right? Look, the point in 5 is 5 point something, right? It's 5 and a little bit more. So that will be the coordinate for x, 5 point something. And for y, look at this. The coordinate for y is, well, it looks like it is exactly 3. Now, we're not sure, right? This could be 2.99 or 3.0001. It could be something like that. But for now, if we get an answer close to 3, then we know we did the process correctly, right? So this is the reason why we want to plot the points first. Right. Let's continue. Now that we know the points, how do we find the exact coordinates of x and y? How? Simple. Just let's use the formulas. So we know that r equals 6 and theta equals pi over 6, right? R and theta. In the chat, Cata Castro says, buenos días, profe. Hasta ahora me pude conectar porque tenía problemas de internet. Cata, don't worry. I understand. Thank you for letting me know, Cata. All right, let's continue. So now that we have our r and our theta, all we are going to do is use our formula. So if we want to find the value of x, then we use the formula for x. From here, simply replace the values of r and theta. That's it. So x equals r cosine of theta. Now x equals 6 cosine of pi over 6. Why? Well, because we know that r equals 6 and theta equals pi over 6. That is what we know, right? Now, all we have to do is put this in a calculator. If we put it in a calculator, cosine of pi over 6 will give us 0.866 again. In case you guys don't remember, this is what we're doing. From here, this cosine of pi over 6, we put it in a calculator. calculator. Man, I suck at writing with this. Sorry, guys. We put it in a calculator, and it will give us 0.866. That is what it will give us, right? So you do that. You do that. Now, this 6, the 6 that we have here, let me do it with another color. This 6 is multiplying the cosine because that 6 is the r. And r was multiplying the cosine. So we leave it there multiplying. The result at the end will be 6 times 6 multiplied by 0.866, right? That is the process right there. From here, just put it in the calculator again, and you know that the result will be 5.196. And it makes sense because look at our drawing. In our drawing, we knew that for x, the coordinate of x was 5 point something, 5 and a little bit more. Well, here it looks like it is 5.2, right? So it makes sense. It looks like we are doing things right. And that is the reason why you guys want to plot the point first. Now, a couple of things before we continue, guys. Take a look at this. Here I am using the sign of equal. Also here the sign of equal. But in here I am using the sign of round. Also here the sign of rounding. Why am I doing so? Well, because in here these are equalities. I haven't changed anything. I just replaced the values. But in here, after I put this in the calculator, after I put the cosine of pi over 6 in the calculator, this number is a round number. We are rounding this number. This one should have infinite decimals, but we are just writing 3. So this is not the precise answer. This is just an approximation. So every single time you guys do an approximation, make sure you do the round sign. This is called notation in mathematics. And I am telling you about this because, as you guys know, I am a teacher of IB. And in IB, you guys will be required, no matter what subject you decide. Maybe you guys pick my subject, or maybe you guys pick another teacher's subject. It doesn't matter. You will have to do a round sign when you are rounding. All right? Write that down, please, as a note or something. Round when you have to round. All right. So now we have our variable for x, right? We have the coordinate of x. Beautiful. From here, let's find the variable of y. This is what we're doing, right? We're finding the rectangular coordinates. So we just found the one from x. Let's find the one from y. To find the one from y, just use the formula for y. R sine of theta. Replacing the values of r and theta, we have that y equals 6 sine of pi over 6. This is a simple replacement. Now, if we put this in the calculator, sine of pi over 6 will be 1/2. Again, the 6, we're just leaving it there because all we did was the sine. This is 1/2. Look at that. In the previous case, it was a decimal that had infinite decimals, so we had to round. But if you go ahead and do this in the calculator, you will notice that the answer is precise. It is perfect. The answer is perfect. It is exactly 1/2. So we don't have to round. We can just use the equal sign, right? From here, if we multiply this, 6 times 1/2 will give us the y equals 3. And look at that. We said so at the beginning. We said that y was something around 3. Well, it looks like it's precisely 3. Precisely 3. How about that? All right. This is the process. How do we write the answer? This is how we write the answers. Look, the rectangular coordinates of the point 6, pi over 6. These are the polar, right? And these are the answers. This is the answer in red. 5.2, 3. We are talking about a point. So we want to put this as a point with coordinates inside parentheses. And that is it, guys. That is it. That is how you use the formulas and you change from polar to rectangular coordinates. Let's do another example. Let's take a look at this one. This is the polar coordinates, but in this case, we have double negatives. Again, first step, we are going to plot that point, right? The angle is negative, so look, I have a negative 45 degrees here. Negative 45 degrees, counterclockwise. I'm sorry, clockwise, right? Going downwards, negative 45 degrees. From here, this should be the line. So this is the 4, but we are not measuring 4. We are measuring negative 4, so we measure in the opposite direction. This is the location of B. This is how to plot points. We know this, right? We know this. From here, given that the point is in the quadrant 2, remember, quadrant 1, 2, 3, and 4. Given that the point is in quadrant 2, we expect the x coordinate to be negative, look, something like negative 2 point something, because it's around here, right? Close to negative 3, right? Close to negative 3. And the y coordinate to be positive, because these are the positive coordinates, right? Something like 2 point something, maybe close to 3. In fact, look, it looks like the y coordinate and the x coordinate could be the same. The only difference is the x is negative and y is positive. That's what it looks like, right? Now, we are not just going to say, oh, the coordinate is 2.8, whatever, negative 2.8. No, we cannot say so, because that would be doing an estimation, doing it with our eyes. And that could give us problems, right? So that is not enough. This is a good approach. This is a good first approach. But we have to make sure, and to make sure, we are going to use our formulas, right? So now, using the formula of x, right, we're going to replace the value of r and the value of theta. Again, negative 4 instead of r, and negative pi over 4 instead of theta. Put this in the calculator, and this is what you guys are going to get. Negative 2.828. So yes, around negative 2.8. And again, it makes sense. Look, x, this is the variable x. So it is around here. Around here. Negative 2.8. We are doing things correctly. Huh? How about that? If we do the same process with y, we're going to have that the coordinate, the formula is y equals r sine of theta. This is the formula, right? Replacing the values of r and theta, and then putting them in the calculator, we're going to have this multiplication here. Multiplying this, we'll have that y equals 2.8, which is a positive value. 2.8 is around here, which, look at that. It makes sense. Ha! How beautiful is that? In other words, in order to change from polar to rectangular, all you have to do is use the formulas and the calculator. That is it. This is how you write the answer. Negative 2.8, 2.8 between parentheses. All right. That is it, guys. We're going to jump right into the exercises. Before you guys do that, I want to show you something. I just want to show you something. Sometimes, when we are working with the calculator, give me a second. Where is this? Like this, beautiful, and there. All right, let me show you something, guys. Take a look at this. You guys have your calculator with you, right? Well, I'm assuming you guys do. All right, let me show you something real important here. Look, sometimes, if we calculate cosines and sines, the result will not give us what we want. Look, let's say I want to find x with these same values, right? So I'm going to do that. Cosine of, you know what? I can do it. No, let me do it step by step. Cosine of pi instead of pi. Don't do 3.14. Don't ever do 3.14 instead of pi. Don't. You guys are going to do cosine, and here, look, here is the pi bottom. The pi bottom here. Second, and this one. There's the pi. Don't do 3.14. Don't do that one. Do pi, all right? So here I have negative pi. So again, cosine of negative pi, right? Divided by 4. Pi over 4, right? I close the cosine there. When I do that and I press enter, this is the result, 0.9999999. Well, that is not what I have here. What I have here is 0.707. So what is going on? Did I do my exercise wrong? Or is the calculator wrong? Look, even if I take that value and I multiply by -4, look, -4 multiplied by ans. Where is the ans? Here, by ans. So I'm going to take the last value, the last answer, and multiply by -4. I am doing this step. The result will be -3.999. Well, it's not this. It's not -2.8. It's not this. Sometimes that could happen. Look, the calculator is lying to me. It's lying to you too right now. Sometimes that can happen. So, and we have one way of letting us know when the calculator is lying to us. Look, we should know at the beginning. We knew the variable of x was something like -2 point something. How is it possible that it's giving us -3.9? From there, we know the calculator is wrong. From there, we know the calculator is wrong. And how can we solve this? Simple. In this case, the calculator is in gradients, in degrees, sorry, in degrees. We just put an angle in radians, but the calculator is calculated in degrees. So that is a huge problem. That is a huge problem. Since the calculator is in degrees, instead of writing -pi/4, I can just do this. Cosine of -45. That is pi/4. It's 45. So if I close the cosine, look, that is the real answer now. Ah, man. Go to negative. There. That is the real answer. -45 is 0.707. My answer. And it is simply because my calculator is configured to accept values in degrees. So I have to make sure I put in the calculator the right angle. Here we had it in radians, but since the calculator is in degrees, I cannot use radians. I had to use degrees. Another way would just be to configure the calculator to accept radians. And this is how you do it. Pay a lot of attention, guys. Here, pressing the mode key. You press the mode key, and look at here. Here you have the options for radians or degrees. Mine is in degrees. So I'll just scroll down a little bit there, and now it is in radians. Press enter, and now the calculator accepts radians. So if I go back, now I can do again cosine of -pi divided by 4. Now look, now the cosine is, the angle is in radians. This is the angle in radians. But if I press enter, the result is the same. Because now I told the calculator, hey, calculator, please accept radians. All right? Okay, guys, that is something I wanted to show you to make things a little bit easier for you. So what I want you to do right now, guys, is to please get to work on exercises 39 to 54. Now, since you guys have a different book than mine, these are probably not the exercises I'm expecting. So I'm going to show you what are the exercises I'm expecting. 726, 726. These are the exercises. These ones. Please go ahead and look it in your book. Please go ahead and look for these in your books. It should be in the page 726 or around there, close to that. Can anybody tell me the real exercises, please? Thank you, Tefa. Man, Tefa is so nice. Thank you, Tefa. So, according to Tefa, the exercises are page 728, exercises 41 to 56. That's it, guys. Get to work.